For thousands of years, people have invented tools to make work easier and more efficient. Yet until the 17th and 18th centuries, most of these inventions merely assisted workers rather than replacing them. Skilled artisans remained the true engines of production, as they possessed knowledge, precision, and experience, and no machine could replace them at that time. Since human labor was the key factor in production, the greatest obstacle to increasing output was labor productivity. A blacksmith, weaver, or carpenter could produce only a limited number of goods in a day. Breaking this limit required an entirely new way of organizing production. That breakthrough came with the factory system, one of the most transformative innovations in human history. It fundamentally changed not only how goods were made, but also how societies developed, paving the way for the Industrial Revolution and centuries of unprecedented economic growth. So, what made factories so revolutionary? The answer begins with machinery. Unlike hand tools, factory machines could perform the same task far faster and more consistently than any individual worker. A single machine often produced dozens, or even hundreds, of times more output than a skilled craftsman. For the first time, production no longer depended primarily on the physical capabilities of human workers. But there was a challenge. Machines powerful enough to replace human labor required far more energy than human muscles could provide. This forced manufacturers to search for entirely new sources of power. One of the earliest solutions had existed for centuries: the watermill. By harnessing flowing watermills could power mechanical equipment and dramatically increase the production of flour and other goods. Although these mills were far too small to resemble modern factories, they introduced a revolutionary idea. Natural forces could drive machines instead of people. This principle would eventually become the foundation of industrial manufacturing. Today, many historians consider Lombe's silk mill in Derby, completed in 1721, to be the first prototype of the modern factory. Ironically, however, the key technology behind the mill was not British at all. It originated in northern Italy, where silk manufacturers had developed mechanized spinning equipment that could produce threads much faster and more consistently than traditional hand spinning. To power these machines, they built water-driven mills alongside their workshops. British entrepreneur John Lombe traveled to Italy, studied the technology, recruited several Italian specialists, and reproduced the system in England. Even so, the factory system spread relatively slowly during its early years. The decisive breakthrough came in 1769 when Richard Arkwright patented the water frame, a spinning machine powered by water. The invention transformed textile manufacturing, increasing productivity by several hundred times. Arkwright did more than invent a machine. Together with his business partners, he built a network of watermills that employed between 500 and 2,000 workers. By 18th century standards, these were enormous industrial enterprises, unlike anything that had existed before. Why did factories become so large? The answer lies in specialization. A village craftsman wore many hats. He produced goods, purchased raw materials, kept accounts, cleaned his workshop, and sold his finished products. A factory, however, was too large and too complex for one person to perform all these roles. Instead, different workers specialized in different tasks, allowing each to become more efficient. This specialization, however, only made economic sense when both workers and machinery operated continuously. Idle machines represented wasted capital, while underemployed workers increased production costs. The larger the factory became, the lower its average costs could fall, a phenomenon economists now call economies of scale. Large factories balanced substantial upfront investment with lower long-term production costs, making them increasingly competitive. Building such enterprises required enormous amounts of capital. Most craftsmen simply could not afford expensive machinery or construct water-powered mills. Wealthy entrepreneurs stepped in to fill this gap, financing factories themselves and renting production equipment to smaller manufacturers. In many cases, tenants received much more than access to machinery. They also benefited from centralized accounting, transportation, storage, and other shared services, reducing costs even further. As industrial technology advanced, machinery became larger, faster, and more powerful. Water, however, imposed unavoidable limitations. Factories had to be built beside suitable rivers, and their output depended on seasonal water flow. Industry needed a more reliable source of energy. Steam provided the answer. Steam engines were not entirely new. Primitive designs had appeared in the early 18th century, but they were inefficient and consumed enormous amounts of fuel. As a result, they were used only where no practical alternative existed, most notably for pumping water out of coal mines. Most manufacturers therefore continued relying on water power until James Watt introduced his dramatically improved steam engine in 1778. Watt's engine was not only several times more powerful but also vastly more versatile. Unlike water wheels, it could operate almost anywhere. Factories no longer had to stand beside rivers. They could be built wherever labor, transportation, and markets made the most economic sense. This single innovation transformed the geography of industry. Manufacturing shifted rapidly toward towns and cities, linking industrialization with urbanization in ways that would permanently reshape society. Even before steam engines became widespread, Richard Arkwright had already encountered one of the greatest challenges facing industrial production. His mill at Cromford occupied an ideal location beside a fast-flowing river, but the surrounding countryside simply could not supply enough workers to operate such a large enterprise. At first, Arkwright recruited workers from neighboring villages. Yet many prospective employees faced hours of walking every day. The journey discouraged recruitment, wasted valuable working time, and left laborers exhausted before their shifts even began. His solution was remarkably ambitious. Arkwright constructed an entire settlement beside the factory, complete with housing, shops, a church, and a school. Workers could now live within walking distance of their jobs, creating one of history's earliest purpose-built industrial communities. Transportation created another obstacle. The nearest road capable of carrying wheeled vehicles lay several miles from the Cromford mill. Even after roads were improved, factories located in remote areas still faced significant difficulties transporting raw materials in and finished products out. Large industrial cities gradually solved both problems at once. They concentrated workers, transportation networks, suppliers, and customers in a single location. Industrialization, however, came at a significant cost. Steam engines consumed enormous quantities of coal, causing mining to expand rapidly alongside manufacturing. Coal powered the Industrial Revolution, but it also filled cities with smoke, soot, and pollution. Manchester and many other industrial centers became famous not only for their factories but also for their dark skies and poor air quality. A reminder that rapid economic progress often carried heavy environmental consequences. Despite these costs, the factory system transformed the world more profoundly than almost any previous economic innovation. By replacing the limits of human muscle with the power of machines, factories unleashed an extraordinary surge in productivity. Higher productivity generated sustained economic growth, rising living standards, and the emergence of the modern industrial civilization that continues to shape our lives today.